Hi, hello everybody. This is Venkatesh Chemistry, your chemistry mentor. So I am going to explain about solubility of solutions. Solubility of solutions. Solubility. Solubility. It is one of the concept in solution chapter. Now, solubility means what here? Solubility means what? The amount of the amount of substance dissolved a specified amount of specified amount of solvent at given temperature is called solubility. Solubility of substance means the amount of substance dissolved in a specified amount of solvent at a given temperature is called solubility. So what are the factors affecting to the solubility? Then here factors mainly first one is nature of solid. The second one is nature of solvent. Then temperature, and fourth one is pressure. So these four factors decided to the solubility of solids in solvents. So that is maybe whatever that is. So solid in liquid, then gas in liquid. So like this solubility we have to observe, right? So nature of the solid, nature of the solvent, and temperature and pressure. Okay. Then another thing is here nature of the solid, nature of the solvent. So solid and solvent similar nature is there, so that should be dissolved in it same solvent. Suppose solid may be ionic in nature, that should be dissolved in water also ionic in nature. So means here polar solids dissolved in polar solvents. Polar solids dissolved in polar solvents. Same thing here, naphthalene and anthracene. So these are generally dissolved in benzene. So naphthalene and anthracene both are here organic compounds. Then benzene is the organic compound. So that is the non-polar solids dissolved in non-polar solvents. Polar solids dissolved in polar solvents, non-polar solids dissolved in non-polar solvents. Okay. Now here example. What is the example of polar solids? NaCl plus H2O. NaCl dissolved in H2O. So because of here H2O, H plus and OH minus ionic in nature. Okay, na? Polar nature. Then another thing is NaCl is Na. It is dissociated into Cl minus. Na plus and Cl minus. So Na plus Cl minus, H plus and OH minus, so polar. So this should be dissolved in water. Then here example, non-polar solids. So what is that? Naphthalene and anthracene. So these are the organic compounds. These are organic compounds must be dissolved in organic solvents. Benzene is the solvent here. Then another thing is CCl4 and benzene. So benzene is the solute and CCl4 is the solvent. So this is the nature of solute and solvent. Then another thing is temperature. Temperature should be increases, and another one is solubility of solid in liquid and solubility of gas in liquid. What happened there? Now we'll discuss now. So before going to that, what is the dissolution? What is the crystallization? What is the dissolution and what is the crystallization? Right? Crystallization. So dissolution means what? Crystallization means what? Dissolution means the amount of substance, the amount of solid dissolved in solvent, then its concentration is increased. So this process is known as dissolution. Okay na? Then when it is a solvent, when added the solid, what happened to them? The solid added to the solvent and its concentration increase. When adding the solid. The concentration must be increased. So this process is known as dissolution. When the solid added to the solvent, the concentration of the solution increase. This process is known as dissolution. And another one is crystallization. Okay na? Another one is crystallization. So you see here one thing, a crystallization means suppose sugar water is there. So after some time where we have to heat it, then water molecules evaporated. So remaining sugar we have to observe. Or generally in a solvent, solid particles contact with each other, then that is converted into solid state. So crystals are formed here. So the process is known as here crystallization. In a solution, solid particles collide with each other to form a precipitate or particles. This process is known as crystallization. Right? So this is the solution. Then it is the solution in which solid and solvent is there. So now these are the solid particles. The dotted lines are your solid particles. Then it is collide with each other. Okay na? Contact with each other. So it gives a bigger molecules. So that process is known as here a formation of crystals from the solution. So that is called here what is crystallization. The next one is types of solutions. Okay na? In this solubility, types of solutions. Okay, types of solutions. So here in which first one is saturated solution, First one is saturated solution. Saturated solution. Second one is unsaturated solution. Third one is supersaturated solution. Supersaturated solution. Supersaturated solution. Saturated solution, unsaturated solution, supersaturated solution. Supersaturated solution. First one is saturated solution. First one is saturated solution. The solution can dissolve some more. Okay, means here. So here solution. Okay, what are the saturated solution? The solutions which the solution which can no more solid dissolved at same temperature is called, what is here, the solid which can no more solid dissolved at same temperature is known as saturated solution. Right? So I will give the explain to you. Here suppose the capacity, suppose one person capacity to eat 10 bananas. The capacity is 10 bananas. The person must be eat 10 bananas, so that should be, he was satisfied. So that means that is a saturated medium. And another one thing is, suppose solvent, this is the solvent, it is 50 ml solvent. This 50 ml solvent capacity, dissolving capacity only 20 gram of solid. 20 gram of solid can be dissolved. Okay na? Then to this added 20 gram solid, so that is the saturated solution, otherwise not. So no more, okay na, which can no more solid dissolved at same temperature, so that is called saturated solution. Then another one is unsaturated solution. Second one is unsaturated solution. So second one, unsaturated solution, this is the first one, and second one is unsaturated solution. Here the solution which can some more, okay na? Same here, the solution which can some more solid can dissolve at a given temperature or same temperature, that is known as unsaturated solution. Some more, that will be needed another some more, solid can be dissolved. So that type of solution is called here unsaturated solution. So here same thing, the 50 ml solvent, we have to add here just only 5 gram of sugar or NaCl, whatever it may be. Then that can be able to another 15 grams also can dissolve in it at same temperature. So that's why this is unsaturated. So the person capacity 10 bananas is there. So the available only 4 or 5 bananas are there. So he was not satisfied. So that's why that type of solutions are called here, what is here, unsaturated solution. The next one is supersaturated solution. The supersaturated solution means here solution is there 50 ml solvent. Okay, we can add more than 20 grams upon heating or rise with the temperature. So that can able to dissolve more than 20 grams. More than 20 grams means we have to adding 21, 22, 23 like that. Okay na? So when we have applied temperature or increase the temperature, so dissolving capacity of that solvent increases. So that type of solution is called what is here? Super saturated solution. So here we are applied another some temperature, but here in this case same temperature. So this is the dissolution process. In dissolution process, one is saturated solution and another one is unsaturated solution, another one is supersaturated solution. The next one is what is the factors affecting to the solubility of solid in solvent. Okay na? Solubility of solid in solvent. Okay. Solubility factors. We know already factors. What is nature of solid, and another one is nature of solvent. Third one is temperature. The fourth one is pressure. Right? Now first one, you know already, nature of the solid and nature of the solvent. So same means ionic solvents must be dissolved in ionic. Polar solids must be dissolved in polar solvents. Like dissolve like. Likes dissolve like. It is the basic principle. Like dissolves like. It is the basic principle. Okay. Now we'll observe. Okay. Solubility of solid in liquids. Now we are going to the solubility of solid in liquids. Solubility of solid in liquid. And another one is solubility of gas in liquid. And solubility of solid in solid. Okay na? So that is also is there. So but we don't know, we are not able to discuss here. So just only we have discussed solubility of solid in liquid, solubility of solid in gas in liquid. The first one is solubility of solid in liquid. Solubility of solid in liquid. Solubility of solid in liquid, what happened there? And temperature effect. So dissolution process. Okay na? Dissolution process. If it is exothermic. If it is exothermic, and when increase the temperature, solubility decrease. Okay na? Increase the temperature. Okay na? Decrease with increase in temperature. Okay na? Increase in temperature. So temperature increases there. What is it decreases here? Solubility decrease solubility when increase the temperature. Then dissolution process. The exothermic means what is here? While during the solubility, heat is liberated, heat is produced. So that is the exothermic process. That process. Dissolution process here, exothermic. Heat already evolved. Again we are applied to there. Solubility must be decreased. Solubility of solid in liquid decrease. Then endothermic. Okay na? Dissolution process is endothermic. Solubility increase with increase in temperature. Solubility increase with increase in temperature. Right? Then another one is, so this is the solubility of solid in liquid. And another thing, solubility of solid in liquid, pressure effect. What is the pressure effect for the solubility of solid in liquid? Okay, solubility of solid in liquid, pressure. So there is no effect to the solubility. Why? Because okay na, solid do not affect by the pressure. Solid do not affected by the pressure, because already molecules molecules arrangement in solid fixed positions. There is no alternative. So they the should be have a fixed positions in that solid state of the um, solid. So now here, that's why pressure does not affect on the solubility of solid in the liquid. The next one is solubility of gas in liquid. Solubility of gas in liquid. Okay na? Solubility of gas in liquid. Solubility of gas in liquid. What happened? Solubility of gas in liquid, what happened? So temperature effect here, what happened there? Solubility of gas in liquid decrease when increase the temperature. Then pressure, when pressure increases, solubility of gas in liquid increase. When increase the pressure, solubility of gas in liquid increase. Okay, how it is? So it is explained by the Henrys, who was a scientist. Okay na? Henrys was a scientist. He was given a relation between the solubility and relation between the solubility and solubility of gas in liquid. Okay na? Due to the pressure inversely proportional to the pressure directly proportional to the solubility of the surface area. Here pressure directly proportional to the mole fraction according to Henrys. Okay na? So according to him, solubility of solid in liquid, Henry's law, according to Henrys, solubility of solid in liquid is directly proportional to the partial pressure of the gas present above the surface of liquid. Okay na? Present above the surface of liquid. So this is the liquid surface. Then it is what here gas is there. Gaseous particles. So solubility of gas in liquid, that is directly proportional to the partial pressure of present above the surface of the liquid. Present above the surface of the liquid or solution. That is called here Henry's law. So he was explained by using the experiment in a one container taken in one container. So in this liquid taken in one container, a liquid, okay, then here gaseous particles are there. It is closed with the piston, okay, then another one also is there, like, okay, same thing. So just first only weight one, keep on that piston, okay na? Then some gaseous molecules dissolved in liquid and increase, weights are increase, okay na? So W1, W2, W3. So means here pressure must be increase upon the surface of the liquid, on piston. So the piston, you see here, this is the liquid as it is here. The gas compressed by the piston, and the number of molecules available on the surface of liquid solution. So the more possibility dissolved in, the number of gaseous molecules are more possibility to enter into the solution. So this means what here, the weight increases means piston, the pressure applied on the gas on the surface of the liquid, the gaseous particles, more gaseous particles enter into the surface of the liquid, enter into the bulk medium of the solution. So means the solubility of gaseous particle increases. Solubility of gaseous particles increase, right? So based on this, he was given a formula. Based on this, he was given a mathematical formula or principle or a law. So that law is called Henry's law. That law is called Henry's law. Henry's law. So what is the Henry's law? What is the Henry's law? The partial pressure of, okay now, here Henry's law means what is here? Henry's law means what is here? The partial pressure of gas present above the present in vapor phase, okay na? Partial pressure of gas in vapor phase is directly proportional to the mole fraction, its mole fraction of a gas in a solution. So this is called Henry's law. The partial pressure of gas in vapor phase is directly proportional to its mole fraction of a gas in a solution. Okay na? So it can be expressed in mathematically P directly proportional to X, right? It is expressed mathematically P directly proportional to X. P equal to KH into X. P is called what is your partial pressure of gas. KH means Henry law constant. X means mole fraction. X means what is here? Mole fraction, right? KH means what is Henry law constant. Henry's law constant. P means partial pressure of gas. Right? So this is the mathematical expression of Henry's law. So Dalton law, at the same time, Dalton also expressed the partial pressure of gases. Okay na? Partial pressure of gases. For the means here, each gas particles that should be have their partial pressure when combined state of the gaseous solution. So means here, so this is according to Dalton, okay na? So at the same time, okay na? At the time, Dalton also explained the partial pressure of gases. According to him, total pressure of the gas, okay na, gaseous mixture is equal to the partial pressure of individual gases. Okay na? Partial pressure of individual gases. Pressure of the gaseous solution or gaseous mixture is equal to the partial pressure of sum of the partial pressure of individual gases. P1, P2, P3 like that. So this is according to Dalton. Okay na? Here also coincide. So he was explained. Who is that? This is Henry's law. Henry's explained the relation between partial pressure and its mole fraction of the gas. Partial pressure and mole fraction of gas, mathematically P equal to KH into X, right? So this is the solubility, then this is the partial pressure. Okay na? So partial pressure, solubility is directly proportional to what is here? Partial pressure of the gas present above the surface of liquid. Now this is the Henry law constant. Now this is when increase means here KH equal to P by X means this is solubility. So it is inverse to KH equal to 1 by X. It is solubility. Then KH increases, solubility must be decreased. So inversely proportional. Okay na? Higher the value of, what is the significance of KH here? Higher the value of KH, lower the solubility of gas in the liquid solution. Okay, so this is what is the graph between the partial pressure and the mole fraction. So partial pressure taken on y-axis, mole fraction taken on x-axis. That should be give a straight line from its horizon. So this is KH. This is what here KH. So KH value, right? So means inversely proportional partial pressure increases, mole fraction of the gases increases. What happened to there? Solubility increase. Okay na? Partial pressure of the gas increase, partial pressure of liquid, partial pressure of gas increase, then mole fraction of gas also increase. Right, solubility also increase. Next, another one is applications of Henry's law. Okay, Henry's law. See here, applications of Henry's law. The first one is this Henry's law used for the solubility. Okay na? Solubility increase when it is pressure increases. Okay na? So suppose generally here cool drinks are there. Okay na? Carbonated beverages, cold drinks, soft drinks. Okay na? In this, carbon dioxide must be dissolved in it. Okay na? So by using the pressure. So that's why these are sealed under high pressure. Okay na? So cool drinks and soft drinks. Cold drinks are soft drinks. Carbonated. Okay na? Cold drinks are soft drink sealed under high pressure. Okay na? Okay. CO2 gas. Okay na? CO2 gas dissolved in soda water at high pressure. Okay na? So here under carbon dioxide dissolved in soda water and at a high pressure. So that's why we have to use under high pressure, sealed under. So these soda water bottles sealed under high pressure. Okay na? Then carbonated beverages. Then another one is second one. This is used for, what is Henry's law used for scuba divers. Okay na? Respiration of scuba divers. Respiration of scuba divers. So why they are used to scuba? Scuba is the special container to use scuba divers. Okay na? The diving members in undersea water. So undersea water, what happens there? Generally pressure increases. When pressure increases, solubility of nitrogen gas, because of oxygen cylinders, nitrogen also present in that cylinders along with the oxygen. Then along with the oxygen, nitrogen also is there. This is immediately soluble in blood cells. So under high pressure or under the sea water. So because of pressure increases. So what happened to there? The solubility increase in the blood cells. Then the persons after coming on surface of the sea level or back to the ground level of the water. So what happened to there? Pressure must be decreased and dissolved nitrogen gases come out from the blood cells. So that must be effect to the blood capillaries, to passage of blood circulation in their system. Okay na? In their system. So that's why automatically affecting is there, some effect is there, so bends are found there, bends are found there. Okay na? Due to the avoiding this, bends formation, the scuba must be filled with helium, okay na, 11.7%, and oxygen 32.1%, and nitrogen 56.2%. So this is must be filled in that scuba. Okay. So why? Because it is not a interact with the blood cells. It is not dissolved in. It is lightest metal. Okay. So that's why we have to use in scuba this mixture of gas for the respiration. Okay. This is one of the application for Henry Swan. Then another one is at high altitude, respiration for at high altitude, or mountain climbers, okay na? Generally some members, some mountain climbers, or who those are peoples lived at high altitudes, that peoples unable to think properly due to the less oxygen available at that place. Okay na? The when we are going to the high places, generally pressure will be decreased, then availability of oxygen dissolving in our blood cells are decreased, then automatically there are also some suffering, phasing that causes disease is called here anoxia. Anoxia means here the people do not think properly, are unable to think properly, who those are living at the high altitudes or mountain climbers. Okay, so these are the Henry's laws applications. In the next video we are going to the osmotic pressure. We are going to the vapor pressure of solution. Right. Thank you for watching this video.